Hello everyone, welcome to this video. In this video, we shall be continuing our question 13 from exercise 9.1 of NCERT. So here we need to first of all write down the first 5 terms of the sequence and then write the corresponding series. So let's move ahead and solve this question. Here the first term A1 is given to us as 2. The second term is also given to us, right? So notice that here n is greater than 2. So that means n can either be 3, it could be 4, it could be 5, 6 and so on, right? So here the first and the second term are given to us. For the third term we need to put n is equal to 3 in the general term, which is an is equal to an minus 1 minus 1. So this term is different from this subscript. So make sure you write the terms correctly and do not mix them. Okay, so when we substitute n is equal to 3 here and here, let's see what do we have. We have a3 is equal to a2 minus 1, and we know what is the value of a2 is 2, right? So we just substitute it here so that we have a3 as 1. Next, for the fourth term, we put n is equal to 4 in the general term. An is equal to an minus 1 minus 1. So that a4 is equal to a3 minus 1, and a3 is 1, so 1 minus 1 is 0. And next we need to put n is equal to 5 in the general term. An is equal to an minus 1 minus 1. So that your a5 would be a4 minus 1. a4 is 0, so 0 minus 1 is minus 1. So now the terms of sequence, the first 5 terms of sequence, they are: first term is 2, second term is 2, third term is 1, fourth term is 0, next is minus 1 and so on. So therefore the corresponding series is, so we just need to copy down the contents. So that would be 2 plus 1 plus 0 plus minus 1, and we write plus dot 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 in order to represent that there are more terms available here, right? So next question here is about Fibonacci sequence. Some people call it Fibonacci sequence. So what is this sequence? This is very famous sequence. It is based on the name of a mathematician, Fibonacci. So this sequence here is given by this term. So first of all, let's see what is this sequence here, right? So let's first of all write the terms of this Fibonacci sequence. So actually they are not asking to us what is the sequence, but let me demonstrate to you what all terms it contains. So here a1 is given to be 1, a2 is equal to 1, right? a3 is obtained when we put n is equal to 3 in the general term, so that we have a3 is equal to a2 plus a1, so that is 1 plus 1, which is 2. When we put n is equal to 4 here, right, we have a4 as a3 plus a2. How? Because you see this is the general term. When you put n is equal to 4 here, when you put n is equal to 4 here, so it would be 4 minus 1 and it would be 4 minus 2. So this would be a3 and this would be a2, right? So the a4 would be a3 plus a2, and you know what is the value of a3? a3 is 2 and the value of a2, it is 1. So we have 2 plus 1, which is 3, right? So this is the fourth term. The fifth term is obtained again when you substitute n is equal to 5, so that it would be a4 plus a3. So it is 3 plus 2, which is 5. The next term would be when we substitute n is equal to 6 here. So a6 would be a5 plus a4. a5 is 5 and a4 is 3. So we have 8 here, right? In a similar manner, we may calculate many terms. So let me demonstrate to you few more terms. So it would be this one, a6 is 8, and then we have 5, which is 13. Next a8 would be a7 plus a6, which would be 13 plus 8, so it would be 21, right? And then we have a9, which would be a8 plus a7, which would be 21 plus 13, so it would be 34, and so on. So therefore what all terms do we have here? Hence the Fibonacci sequence looks like this. The first term here is 1, the second term is 1, so let's copy the contents here. 1 comma 1, the third term is 2, then we have 3, then we have 5, right? So it is 2, 3, 5. Next term is 8, 13. So let's write down 8, 13, and then you see actually what is happening here, we are just adding them. We are adding these two to obtain 2, right? Then what we are doing, we are adding these two to obtain 3. Next what we are doing, we are adding them together to obtain this 5. Next what we are doing, we are adding them together to get 8. Next what we are doing, we are adding this 5 and 8 to get 13, and so on, right? So that here 1 plus 1 is 2, right? 1 plus 2 is 3. Next we have 2 plus 3 is 5. Next we have 3 plus 5 is 8. Next we have 5 plus 8 is 13. Then 8 plus 13, how much is that? It is 21. Next 13 plus 21, that is 34, and we keep on going like this. This is our Fibonacci series. Now in our question they are asking, we need to calculate a n plus 1 divided by a n for the value n is equal to 1 to 5, right? So we need to calculate this ratio. So in order to calculate, so let's come to our question. To calculate a n plus 1 divided by a n when the value of n is equal to 1, 2, 3, 4, 5, 1, 2, 3, 4 and 5, we have the terms. First of all, when we put n is equal to 1, we have a2 upon a1, right? When we put n is equal to 2, we have a3 upon a2. Then when we put n is equal to 3, we have a4 upon a3. I'm just substituting the value of n here for 1, 2, 3. Then we are substituting the value of n as 4, so that we have a5 by a4, and then we are substituting the value of n as 5, so it would be a6 by a5. Right, now we have all the values. This is a1, this is a2, this is a3, and so on, right? So we can substitute the values. A2 is 1, a1 is 1, so our answer here is 1. Next a3 is 2, a2 is 1, so our answer is 2, right? Next a4 is 3, then we have a3 as 2, so it is 3 by 2, which is 1.5, right? Or you can just simply write it 3 by 2 only. Next, the value of a5 is 5 divided by 3, so the value is 5 by 3. Next, the value of a6 is 8, so we have 8 by 5, which is just 8 by 5, right? So these are the values that we were required to calculate. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.